blackbody radiation, and quantized energy. At the start of the 20th century, our understanding of the physical world was changing rapidly. The electron had been discovered. There was evidence that the atom, which had been considered to be the smallest particle of matter, actually had an internal structure and could change. Cathode rays were found out to be particles, electrons, and the distinction of ray-like properties, light and solid matter, particles, was becoming blurred. Next, the very nature of light was to be challenged. Blackbody radiation. All objects emit electromagnetic radiation, which depends on their temperature. It's thermal radiation. A black body absorbs all electromagnetic radiation, or light, that falls on it. And as they do, they heat up. Because no light is reflected or transmitted, the object appears black when it's cold. However, as the black body heats up, it begins to emit light or electromagnetic radiation based on its temperature. That temperature-dependent spectrum is called blackbody radiation. At normal temperatures, at room temperatures, we're not aware of blackbody radiation. But as objects become hotter, we can feel the infrared radiation heat coming off of them. And as the objects continue to get hotter, they begin to glow. I'm sure you've seen this with an iron stuck in a fire. They begin to glow red, and then as the temperature continues to go up, they advance in color through yellow and then to white, like the filament in a light bulb. Vilhelm Mean, through experimental observation, looked for a relationship between the temperature of a black body and the spectrum of light given off by that black body. He found a relationship between the wavelength or color of the peak of the distribution and the temperature of the black body. This was lambda max times T is equal to a constant, 0.28978 times 10 to the negative 2 meters Kelvin. This is known as Wien's displacement law, and it shows that the higher the temperature, the shorter the wavelength of the peak color of the light. As an object gets hotter, it changes color from red to orange to white to blue. The reason why you see a color like white is that the peak is simply centered in the middle of the visible spectrum and is reminiscent of the temperature of the surface of our sun.